Yeah. So,
Somil, can you please introduce sir so that we can start with Professor Marcin's talk?
yeah. Thank you.
Yes, ma'am. Uh, Hi, good evening.
Thank to
Am I?
Bala Subramaniam sir first, and then start with Professor Marcin.
Yeah. So thank you, Professor Balasubramaniam. It was a great talk from your side, and I think a lot of people must have gained a lot of experience and from your insights. So hoping for a good acknowledgement, and yeah. Uh, Starting further, good evening, everyone, and it is my absolute pleasure to extend a warm welcome to Professor Marcin Paprzycki, an esteemed academician and researcher whose illustrious career spans decades of groundbreaking contributions to fields like software agents, semantic technologies, high-performance computing, and data analytics. His academic journey began with a Master of Science in Numerical Methods and Programming from Adam University, Poland. He earned his PhD from Southern University, Texas, with a focus on the parallelization of boundary value problem solvers. He also holds a Doctor of Science from the Bulgarian Academy of Sciences, where his work on high performance algorithms for matrices with block structure. These achievements highlight his exceptional academic foundation and commitment to advancing knowledge in his field. We eagerly look forward to his insights of frugal artificial intelligence, a topic that promises to spark thought, provoking discussion, and broaden our understanding of AI's transformative potential. Please join with me in giving a warm welcome to Professor Marcin Paprzycki.
Okay, before I share my screen, I would like to express my deepest gratitude to my great friend, Professor Shelly. This is absolutely fantastic opportunity to meet you again. Unfortunately, we are meeting again online. So next time we have to meet either in Aizu Wakamatsu or in Delhi. Konbanwa, Shelly-san, and let's start, guys. Konbanwa. Okay, so what I am going to do, I should be sharing my screen, and at this moment, yeah, we ran into issues because my presentation is not showing. No problem. Uh,
Hello, Professor. Professor Marcin, are you there? Professor Marcin?
completely. I will try to share again, okay? You can hear me, yes? Hello, can you hear me?
Yes, sir.
Yes, Professor.
Professor.
Now we can hear you.
And now you can see the slide.
Yes, Professor.
Okay, good. So I'm gonna add Przemek Hołda, Maria Gansza, myself, and members of our team in the Systems Research Institute, Polish Academy of Sciences. since I'm gonna close all the other things, please, if you have any questions, comments, or if you don't see something, try to say something, not raise your hand, because I am likely not being able to see it. Now let's see if the presentation is gonna move, which is, oh God. Okay, so now you should see the first slide, which says recent trends in AI. Can you see it?
Yes, Professor.
Yes, sir.
Okay, good. Good. So let's start from this, that in the artificial intelligence of today, one of the big trends, especially since the last 12 months, maybe 24 months, 2 years, is building very large models. Very large models mean various things, but generally speaking, we are talking about things that are, from the perspective of the previous research in artificial intelligence, enormous. So we have models that have billions of parameters. Billions means actually billions of parameters. But then they are built on the basis of enormous amounts of data. And as a matter of fact, one of the comments that I have seen recently in a couple of places is that we are running out of training data because practically all of the internet is already included in some of the largest models, either from Google or from Microsoft or from OpenAI or others, which of course brings the question of who labeled this data and can we use supervised artificial intelligence, which is a general question that I will be alluding to in various moments during my talk. Data labeling and pre-processing is, of course, required because if you want to train large data model, you need to first prepare your data, you need to scrap it from collect it somehow. And then after you collect it, label it somehow and pre-process it. And by the way, the pre-processing and labeling often is a hand-in-hand work of humans and machines to start up for the cold start. It takes days to train. Okay, and so we are observing this power-hungry, data-hungry monsters being created, which is kind of fun, except that this has large amount of negative ecological impacts. And here, I would like you to start from you thinking, especially those of you who are a little bit more experienced, about the climate changes around you in India. Because, the heat waves, the severity of the storms, the severity of the flooding. If we are talking about large models, we are talking about enormous amount of CO2 associated with training them and using them because we need energy. So just in case you missed it, right now Microsoft is working to purchase the Three Rivers nuclear power plant in United States. It is someplace, I think, in the New York State, Pennsylvania, that area. And this nuclear power plant is now not operating. But Microsoft wants to buy it, restart it, and use the energy. They want to put next to it, in a sense, enormous data processing center, and they want to train large language, well, not necessarily language, large models, let's say large generative AI models, and use to train it all the energy from a nuclear power plant. So there will be like a nuclear power plant totally devoted to training models. Okay. Energy consumption. Recently, and Professor Shelly had a chance to listen to this talk. We did some evaluation on a text processing, text data. And of course, this data about electricity consumption is not very public because companies don't like you to realize that if the company that we worked with and our student Agata issues 10,000 prompts to ChatGPT 4.0 Mini or 4.0 Turbo, no 4.0 Mini, then the average the use of electricity is the same as use of electricity of an average household for 1 hour. And we are just talking 10,000 prompts. And if you think, okay, think about this, all of the people in India who have access to internet. So let's say just all of the students and all of the people who work for IT companies in India. There are millions of those. And all of them start playing with ChatGPT like ChatGPT is just a name of a generic AI model, but there are many of those. If everybody starts playing with this, think about the amount of energy that will be used to prompt engineering. Okay. Then there is water consumption, half of a liter for 20 prompts in a conversation. This, of course, this data is anecdotal. Training 700,000 liters of water for cooling of ChatGPT like model. Now, it's anecdotal because, again, companies that are doing it, like OpenAI, they will not share with you how much water is being used, okay? They will not admit it. But if you think about this amount of water, right now, apparently in some data processing centers in Arizona, the surrounding ecosystem is destroyed because of all the water which is being used by the computing center before it's released to the air. And when it's released to the air, it travels someplace and it comes as a torrential tropical rain. And then everything is floating. I'm not sure if you have seen the photographs from recent tropical storm attack in United States and the amount of flooding there. And of course, you don't need United States because if you think about flooding in India or in Bangladesh, then you realize how dangerous it is. So climate change is around you. And those of you who are more experienced, not older because we never get old, can think about weather 10 years ago, 20 years ago, and the weather now, how it all changes. So there is also one more aspect of all of this. We are getting more and more computational devices everywhere. So the question is, should we really believe that sending data to the cloud is the best way of processing information in a long run? Network latency. Well, okay, it's getting better, but security. Are you sure that your data is secure? Privacy, and we will come back to this on the next slide. Data may be too heavy, video, images. And now I want you to immediately think about the previous talk. Because if you start thinking about medical images, and medical images here are extremely good example. They are not, I mean, in the medical image area, it is important to get as high resolution and quality images as possible. Now, what does it translate? Because, one person can tell you, oh, we want high quality, high resolution images. And you are like, yeah, this is what we need. This means that you need to have a lot of pixels, but by a lot of pixels. And you need color, which means that those images start to be monsters, okay? They are really heavy. And this means the question is, can you, even if you could, is it appropriate to send it to the cloud? I mean, the network that gets all of this data generated, let's say in a clinic, I'm gonna have a, virtual example of a clinic, but let's envision, and here my distinguished colleague from IIT probably could tell us more because I am not a specialist, but assessment, how much data is generated daily in a medium-sized private clinic in India from X-ray, tomography, USG images, from EKG data and any other laboratory data. Okay? Daily production of data. And how does this daily production of data, is it reasonable to assume that we will send it to some cloud infrastructure? And this is why this slide is particularly for you for medical data processing, because I wanted to draw your attention to the fact that while talking about cancer detection in medical images is absolutely crucial use of artificial intelligence. And for me, using artificial intelligence for cancer detection makes sense, while writing poems using ChatGPT is absolute nonsense. Still, the amount of data which is being generated for model training and then for inferencing is enormous. Okay, and we need to reflect on this, that there is no free lunch other than when I come to Professor Shelly for a conference and then I get free lunch, but somebody paid for it anyway. I put Dehradun because this was the first place I was ever in India. I visited Dehradun. So I'm thinking about private, medium-sized clinic, not in Delhi, by the way. It's a deliberate choice because I want this medium-sized clinic to be removed from all the infrastructures which are available in places like Mumbai, Chennai, or Delhi, which are big cities with a lot of IT companies that have a lot of IT infrastructure. I'm talking about places which are not in small towns, medium-sized towns, medium-sized clinics, and the amount of data they generate. Okay? So now, while they are generating very large amounts of data, I would like to suggest to you, and I hope that if my distinguished colleague from IIT is still here because I cannot see it, if he was able to say something, I would say that amount of data from such one private clinic may not be enough to train robust models. So you need to somehow deal with this, which is something where federated learning would be appropriate. I will not be talking today about federated learning, but this part here, training robust models, is it's about training and federated learning. For instance, privacy. I don't know, and it's a pity that I am not right now in Delhi because we could talk and you could elaborate to me, because this would be for me very valuable. What are currently the privacy laws concerning medical data? But I would say that in very large number of places around the world, and most likely also in India, if this is a private clinic in Dehradun, then getting the data out of the premises would be violation of the rights of the patients, and patients would not be happy. But then if you cannot get those resources out, what are the available computational resources? Well, you don't expect the clinic to buy a supercomputer. Connectivity and security. Okay, let's assume that we can sign some kind of an agreement with India government, Ministry of Health, that there will be special provision to have data which is anonymized, that will be sent to some, India Health Central Cloud, someplace, courtesy of Microsoft maybe, or maybe run by Tata Consulting Services. I know that Tata Consulting is doing a lot of work on medical data processing, because when Dr. Lipika Dei was still there, we talked about it a little bit one day. But connectivity can be slow. So what can you do if you need fast analysis of images? Can you do this over the networks? And by the way, who will label the data? So there is like a whole set of issues that I want you to, one thing is to think, okay, I have collection of medical images, and now I will develop the best possible artificial intelligence to analyze those images. And for instance, use convolutional neural networks to do the cancer detection. And then I will improve my artificial intelligence model to have better quality cancer detection or earlier cancer detection, because as we know, the earlier the detection, the better the chances for survival. Fine, fantastic. But I want you to look at it from the other side. Where is this data gonna come from? Where it's gonna go, and what does it mean? Now, in recent trends, now that we started to observe, and those are the news from the last 3 to 6 months, maybe 5 months. So first, and those are just the titles, okay? And I am just pointing this to you to show that there is also another trend, which is NVIDIA AI releases Minitron, okay? New series of small language models that are 40 times faster training via pruning and distillation. Okay, so we start to see this. Microsoft reducing AI compute needs with small language models. Tech disruptors. This is the message from Bloomberg. The amazing rise of 1-bit LLMs for building faster and slimmer generative AI apps. Small language models from Forbes. And this is the news from the 23rd of November. So it is like 3 weeks old, okay, from last month, 1 month old, not even. Now, what are those messages telling us? Well, those messages are telling us that people started to realize that going large language models or going generative AI, going stable diffusion ways may not be sustainable in a long run. Okay, it is likely that something has to change, that that we need to look at it from the different perspective. Not necessarily, and by the way, I am not suggesting to kill the generative AI large. I'm just saying that we need to go towards frugal AI. And by the way, the images that you're going to see were generated by Professor Ganja using some of the Gen AI models. I'm not sure if she used ChatGPT. I think that it's ChatGPT. So she was prompt engineering while being in Japan and preparing the talk, because originally she had a version of this talk that she presented at University of Aizu. But I'm taking it in a slightly different direction. But generally speaking, those are, and by the way, if you don't like them, yeah, this is the best prompt engineering we could get. So what is Frugal AI? Because I wanted to talk to you about Frugal AI. So Frugal AI is, there's not a single thingy that you name Frugal AI. This is more of a way of looking into the world and realizing that machine learning models need to be capable of dealing with small data, weak devices, uh, human resource utilization for data labeling. And by the way, all of the area of federated learning, which I will not be talking about today, is also about frugality, because it is to allow training data locally and then building a larger model without stretching everybody and generating this extremely large data set in the cloud. So, for instance, for my example of a medical clinic in Dehradun, now let us assume for a moment that we will have 5 clinics in Dehradun, 10 clinics in Lucknow, and few other places. So we will have this collection of, let's say, 100 clinics. And then each one of them will be helping developing a robust model for cancer recognition, for cancer detection in X-rays, but none of them will be sharing the data. The data will be staying within each of the clinics, and the only thing that will be changed will be parameters to the model, which means that we will have absolutely perfect story for network frugality. Data processing will be close to the edge on not so powerful devices, totally asynchronous potentially, and all those clinics together without any intrusion into privacy of their clients, of their patients, they will not be doing, they will be working together. And at the end, there will be this pan-India model of cancer detection for X-ray images with everybody contributing just a little bit. Okay, but I am not going to talk more about federated learning because it's a story for a completely different talk, maybe someday in the future. So most popular approaches to frugality other than federated learning: active learning, zero few-shot learning, quantization, pruning, knowledge distillation, dataset pruning. We will talk about this, and binarization. Binarization is an extreme quantization. This is what they use from that I showed you a few slides back. Okay, this is the 1-bit LLM from Forbes. This news is about binarization. So you represent, your model becomes full, built out of binaries, nothing more. Okay, I will make a comment or two about this, but I'm gonna now go through the other approaches, and I'm gonna try to introduce you to them to some extent. Okay, so active learning. What is active learning? Active learning primarily is for dealing with not enough labeled data. So in a sense, you have some oracle that you are asking to label data, and labeled data are added to the training set, which is improving the training of the model. And you know, the oracle can be the model itself. So you are systematically improving the quality of your model, and you use it to label the data to get more data to then uptrain the model so it will get better. Okay. In general, usually there is a role for the human in the loop. So at the beginning, especially when this whole process starts, you have human in the loop, and the human is acting as an oracle, labeling certain amounts of data and checking the quality of the model, and it goes in circles. Now, think about, since we are talking mostly about medical data, you can think about this as follows. In a clinic, you have a doctor. A doctor is working with a decision support system. Here I'm gonna go back to the scenario that can be set up with my distinguished colleague from IIT, where there is a decision support system for a medical doctor for cancer detection. And what we are doing there, it's trained. Now, this thing is making suggestions to the doctor. There is a cancer here. And the doctor, because the doctor has to do this, gets those data, those images, and answers, well, first, uses it to provide diagnosis to the patient. So we are not excluding the doctor from the process. It's a decision support system. However, now think about how interesting it is, because the doctor, by the very fact, okay, that he is providing Mr. Kumar with the diagnosis and says, Mr. Kumar, I have good news for you. You are not having a lung cancer. This means that a specific image of Mr. Kumar's lungs, which the system, the computer decision supported system said no lung cancer, doctor verifies, presses one thing on the keyboard or on the screen and says, yes, there was no cancer here. And I now have new image. This new image has been verified by an oracle. The oracle is the doctor himself or herself. So when she verifies, or there is, you know, another person, and then the model says, there is a cancer here. And Dr. Shelly looks at it and says, yeah, I see the cancer here. I'm sorry, sir, you have a cancer, but it's a small one. We will deal with it. We will do radiation, whatever, chemo. And then Dr. Shelly will verify this image, yes? So this way, after a day of hard work of your doctors, you get, I don't know, additional 30 images that have been labeled, and they can be then overnight, you can uptrain your model with the new set of images. And you can keep on going like this, developing better and better model. Now, this is an approach for human resource frugality. Then there is zero fusion learning, and this is done, a lot of work is being done, where the reflection here is that you have data for like one-shot learning, where each new class has one labeled example, few-shot learning, zero-shot learning. This is how to deal with new data, new classes, where some elements of the old data are being used, but the metaphor for you is, okay, so I'm coming from Poland. Let's say I've never been to India. Well, I've been now. And there is an absolutely new bird that I didn't see in my life. But I still can say, hey, it's a bird. Okay, I have never seen a creature that is like in those colors, in this shape, in this size, because this specific bird lives only in Gujarat and just eats mango. Okay, it's the famous Gujarat mango eater. Okay, so the famous Gujarat mango eater I have never seen in my life, but I can still recognize, hey, it's a bird because it looks like a bird. Okay, it has a lot of features that make me say it's a bird. Okay, but I would say that with the current state of the art of this approach to frugality, where your amount of data is small and then you introduce new categories, I would say for medical data, not exactly, because right now the quality of results from zero-shot learning may be good enough for writing papers, but not to use in a clinic. Okay? Pruning. This is one of the more popular approaches because what you do, okay, guys, think about this. You have a neural network. I'm not sure how many of you tried it ever to print for yourself, or not print, meaning not on paper, but to see what are the weights in individual neurons. Okay, so you have a neuron, and this neuron has weight at the level of 0.0001. You know, you start to think, is it really that this neuron, this specific one, actually contributes to whatever the neural network is doing? So the idea of pruning in general, okay, let's before we go into more details, the general idea of model pruning is to you train the model, and as you see that some parts of the model are not doing anything, okay, they are not contributing, they are close to zero, then you may want to get rid of them. Now, what does it mean, get rid? Okay, you can remove individual neurons, connections, based on criteria. You know, typically, if something is below a certain threshold, you remove. But usually, from the point of view of software, neural networks, it's not easy to like remove things. You can mask it, in a way. You can turn all those things which are close to zero, you can replace them with actual zeros. And you could possibly even remove them in an unstructured way, but then you need special very complex representation of your neural network. So masking with zeros is recognizing that this neuron or those weights don't contribute, but it will not reduce the size of your model. Now, there's structural reduction, which removes, let's say you remove one layer, okay? You channel, you just get rid of it. Then you can get actual reduction of the size of the model, but remember, this means in both cases that you need to really go to the level of representation of the neural network. You cannot do this from the point of view of high-level software library. This is hands-on work inside. Yes, there are already pieces of software that will do this for you, but and the situation changes, but initially there was mostly masking by zeros. Now, you need to keep in mind that any, okay, you can get model that is maybe smaller, maybe faster, depending on what it means actually pruning for you. You can then improve generalization by some regularization, but still, regardless of what you do, accuracy decrease is possible. And I will comment about this in a moment. So, in general, if you hear network pruning as an approach for medical data, because I understand that you guys are particularly interested in medical data, I say big red light, because you may get accuracy decrease. Accuracy, by the way, here is not, the definition of the accuracy. It is accuracy understood as quality of results may decrease. So you can do this, but this is not something that will be done automatically. You need to fully control the quality of the results while you are pruning. And here you have some idea. This graph is, by the way, a little bit screwed up, but the graph says that what you need to do if you are pruning, you prune things in rounds. So you slowly move towards sparsity, removing things that are not needed. But then after each round of removing, you are running further training. So you can think about it like this. Let's say I have neural network. It has whatever large number of, it's large neural network. After I initially train it, I take and I remove 10% of weakest, smallest weights, neurons, whatever. Then I go back and I run, I don't know, 10 rounds of training. Then I remove additional 10% and I run 10 rounds of training till I get back, recover some of the accuracy loss. And if you see, the best results were you can get 75% less, but you do 10 rounds of remove a little bit, uptrain, remove a little bit, uptrain. And this is how you do this. Of course, there is no free lunch. Look, your accuracy will be around here, or here, or here. So you're gonna lose. But if you slow down the process, okay, you just prune a little, uptrain, prune a little, uptrain, you may be okay. Knowledge distillation. Knowledge distillation is sort of teacher-student model. So you have the teacher model, Then you have the student model, which is smaller, and you try to teach the smaller model on the basis of the teacher model. So you are distilling and transferring knowledge from the teacher model to the student model. And there is a lot of, I mean, this work is quite popular nowadays. And because it involves guru and student, it's somehow related also to reinforcement learning. You can transfer various things depending on what it is that you are interested in. It's an active research area. By the way, all of those things that we are now talking about are active research areas. So, for instance, I believe that there is a potential for a very interesting collaboration. I'm not sure if the professor from IIT is still here because I see only my screen. But if he is here, for instance, getting some projects in which there would be no distillation. Oh, by the way, those results here are done on EKG, so heart studying, electrocardiogram data. So those results here were done on electrocardiogram data by student Przemek Hołda. Okay, quantization. Quantization is this reducing the precision of numbers. Okay, so instead of having, let's say, 32-bit floating point numbers, you use 80-bit integers. Or you can even go down to 1 bit. This is the binarization, which is the most extreme form of quantization. Okay. So overall, it reduces the memory footprint and speeds up inference. Does it? Well, okay. It only does it if you have, for instance, the inference, if you can properly use the existing hardware to run the shorter versions. If you have 32-bit floating point hardware, and instead of going to 8-bit integers, you would try to go to 8-bit floating points, hardware may not run it. Okay, so 8-bit integers will be good only if your processor can run efficiently 8-bit integers, which may not be the case because there are those hardwares, those processors that don't run efficiently 8-bit integers because in the hardware they are 16-bit. And for them, switching to 8-bit integers is not fun. Again, I wanted to point your attention to the fact that here you are really going down to the hardware level. If your hardware supports specific set of machine instructions, and by the way, guys, this is not the place to think, seriously think Python, object orientation. To understand what happens during the real serious quantization, you need to understand hardware and machine level instructions. If the assembler for a given processor gives you what you need, the way you need it, you will be happy. If everything will be emulated, you will not be happy. And this is, by the way, if there are any students here, and you got yourself a course based on the book by Hennessy and Patterson, and you are asking yourself, why do I need to learn about machine instructions? Why do I need to learn about hardware? If there are here teachers, professors from colleges, and your student comes to you and say, I hate this hardware course. Why do I need it? I write all my code in Python. You say, because if you're going to be talking about Frugal AI, and you're going to think about quantization all the way down, maybe to binarization, or maybe just going to 4-bit integers from 32-bit floating point numbers, then you need to understand what the heck you are doing. Okay? So this is your argument for yourself or for your students why computer hardware courses matter. So this is the size. And here there are two things at once, which is the pruning together with quantization. And you can see that you can actually, this was done, by the way, again, for a neural network running on the electrocardiogram data. And you have here 2-in-1, which means you are pruning and quantizing, and you can seriously reduce the model size. By the way, inference performance with quantization is also when you do the pruning and you quantize. Here there is something funny because we didn't observe improvement in speed of inference. Quantization did not help. Pruning, yes. Quantization, not, which was an interesting effect. Here are some results from the electrocardiogram data, so medical data. So the full model, AUROC was 0.93. Authors of a paper of the data set that we used, they had AUROC 0.93. Now, pruning, serious pruning, 0.9024. Quantization was less problematic, and knowledge distillation improved the results. So, look, and here is again thinking about medical data. If you build a medical image, medical decision support system for the electrocardiogram data, if your original model, large one, was running at AUROC 0.93, and you can do quantization and you can seriously reduce the model size, and then apply knowledge distillation, and your results will be of the same general order, but you're going to have something much smaller and faster, potentially, then this is a good scenario, because you can say, okay, I can put this in a much smaller device. Now, some results from a project that we have been running. So the first one, all of them are related to a construction site. This is an actual construction site on which we have been doing things. So this is building in Warsaw. This is the backdrop is Warsaw. And this is the construction site, and we are concerned with safety of workers. Okay, this is rotating itself. So what we are talking about? Health monitoring, danger zone alert, protecting gear, monitoring control, and fall detection. So those are all these things that are related to construction workers. Again, by the way, this thing, remember, all the images generated using a generative AI. So for construction workers, situation changes slightly, because what is important is scalability, energy efficiency, ease of implementation, robustness, employee data privacy, reliability, and low prices. Because whatever you're gonna use, you need cheap, highly durable, weatherproof, comfortable to wear. for workers, devices. So we have been playing with this thing in which you had, here is the gateway, Gwen, gateway and edge node, which you can put, in a box. Now this is beacon, and then there is the Gwen box, which, by the way, can run, it's from company Newways, which was our project partner, and can run 5G. You have localization tag. So this is what workers use. And then this is the stupid smartwatch. It's not smart band, and this is like a smartwatch. And we said, this is cheap. This thing costs around, well, on the market, $20. Okay, I'm not sure how much this thing would cost in India, but probably it wouldn't be too expensive. So here is your device. It has 64 kilobytes of RAM and very low power processor. Okay, so we had to, this is Pine Time Watch. Pine Time is the name of the company, and it is for health rate monitoring. Okay, so this is data collection. So we were, in the laboratory collecting data. This is the watch, and this is Piotr, who has been anonymized, but this is Piotr, and we were collecting electrocardiogram electrodes. There was need for heart rate correction procedures. The model was limited to at most 100 parameters, 100, because it was running on the device. So on this device, with the RTOS operating system on it, we were able to put only 100 parameter neural network, which looked like this. Okay. So the total size was 6,500 bytes. So this was very small. And there is a paper about it. We got it working. So the point here is that if you know what are the restrictions of your device, you can do certain things to fit in and still satisfy the requirements of the company. Okay, then we did dangerous zone detection. Here is, and this is the moment when Carolina is walking into a model. They are walking around the building. And this building is using so-called beam technology, which allows you to dynamically, day by day, establish which zones are dangerous. Here is the dangerous zone alert, which was set up. So there's the Pine Time. This is your watch. Then there is the Edge Data Broker. There is the dashboard. And here is the important part. This is the construction site health and safety monitoring officer who has a tablet, mobile device. Okay, and this is what you see here is that you can see the knowledge graph that represents the situation on the construction site. And you can detect, for instance, that somebody enters the wrong area or enters the construction site at all. Okay, this was done. Here you have, if somebody's heart rate is too high, this is like a model, a depiction of this Pine Time watch, and you get like a flashing warning. And then if you are in a detection zone, a danger zone, you get also a notification. So here you have notifications, and here you have the something that is happening on the dashboard of the safety manager, okay, which is like, hey, Monica Kobus is in the wrong place. And then if somebody comes into the construction site without the helmet, this is like not much of a, well, it is a little bit of a frugality, because this is what you have. And you need to discover that somebody, let me show this to you once more, that somebody is coming without a helmet. And by the way, this guy is bald. And we were able to discover that bald and helmet are two different things, which is kind of fun, okay? So the last one was fall detection. And fall detection is very important because even if you have a harness, it may not save your life, because if you fell down and you are hanging in a harness and you are not found fast enough, you may still die. Okay, especially if you are hanging upside down. So we developed a system for fall detection, and here is when we collected the data of various things in the lab. And here is, oh, here you see fall detection. So Carolina is doing fall detection. And we also use this guy on the right-hand side for fall detection because in the watch, there was an accelerometer. So we were training data on accelerometer to establish when a fall occurs, okay? So again, for each of those problems, unfortunately, we were processing medical data, of course, heart rate, accelerometer. It's not medical, but we were supporting it within the context of our work. And then we, at this moment, I would say, Frugal artificial intelligence needs more work, especially that Frugal learning, in the case of lifelong learning or continuous learning or continual learning, is a problem, has a problem, because if you continue training something, you may run into catastrophic forgetting or concept drift. Remember, I showed you this active learning Frugal case. Frugality means that you have less parameters. If you have less parameters and you keep on training the model, which you have to do because you may have concept drift, you may have catastrophic forgetting, because catastrophic forgetting is related to the fact that you have smaller model. So the smaller model is maybe trained well to deal with a specific problem, but it's more prone to catastrophic forgetting. By the way, this is kind of a joke, and I am about to finish my talk, but this image, Maria wanted the ChatGPT to represent in its own ways. And okay, so this is what Maria figured out as the image of current and future challenges for Frugal AI. This is what ChatGPT produced. And okay, I am not commenting on this. You see yourself what ChatGPT-like models are capable of producing for you. I am not impressed, but hey. So, medical data and frugality, and as you can see, I am closing. Medical data-based AI requires high-quality predictions, much higher quality predictions than other cases. You know, if you make mistake, even in a construction site, or if you make mistake in false news detection, or if you make mistake in sentiment analysis, probably the problem will not be this serious. But if you make mistake in anything related to medical data, this is clear and present danger. Okay. If you misdiagnose somebody, and we are coming back to the fantastic talk of my predecessor about cancer image detection, about cancer detection from medical images. If you make mistake and you don't spot the cancer, and doctor doesn't spot the cancer, the possibility that the patient is gonna die very fast, because the next time the patient comes, she may have a cancer which is untreatable. Quality of prediction matters. So any frugality that is likely to introduce some degradation of performance, which means the quality of predictions will be lower, is a serious problem. This brings us the question of trust. We need that patients trust what we have, but they will trust only if what we have works. But this brings us the question of explainability. Explainability combined with frugal AI. What's the relationship, and how can we make sure that in frugal models explainability stays? Now, each approach to frugality requires extra caution, focus, attention, and manual control at each stage. Different scenario, different approach may be better for frugality. Different hardware on which you're gonna run the frugal model, different approach may be needed. Remember my comments about machine learning, machine instruction sets, and available hardware. So there is no single silver bullet. So the completed experiments brought promising results. I am particularly proud of the results on the construction side, which we hope that Mostostal, the Polish company, will one day actually try to use for the workers. But a lot more research is needed, because what is needed is combination of different methods. We need more understanding how to represent capabilities of devices to pseudo-automatically select approach. And here I would like to invite those of you who would like to do this to collaborate with us, maybe do some research under our supervision or with our help, because the area is enormous. And this is where I'm gonna end sharing. And this is where I'm gonna stop my talk. Thank you all very, 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 very much for being here. I know that in India it's very, very late. So I was trying to be a little bit more compressed to give you time for a few questions, and then you can go and have some paneer. You know, I'm thinking right now having a great paneer dish. Oh, I'm starting to salivate. So you must be now hungry. Think paneer is waiting. Okay, thank you.
Thank you, sir. I would like to extend our heartfelt gratitude for delivering such an enlightening and thought-provoking lecture on frugal artificial intelligence. We are deeply thankful for your generosity in sharing your knowledge as well as for taking the time to engage with us. Your lecture has not only enriched our understanding of AI, but has also sparked the ideas that we can carry forward in our own work and discussion. Once again, thank you, Professor, for honoring us
There
with your
is
presence.
already, by the way, there is already a question. And okay, first, you need to go. I cannot type in this chat because I am from the outside. But if you go for my name and then you go for 2 papers in MDPI that are related, one to fall detection, another one for heart rate prediction. There will be links because the 2 data sets, I believe, are available in Zenodo European repository. So to answer the question from Dr. SSK, I don't know, this is how it. So I think that this is gonna be from Dr. Saumil Shankar. The data is available. The two data sets are available. Okay, at this moment, there should be in Zenodo. Zenodo is the European General Repository, and in those 2 papers, there should be links. If you cannot find them, it's easy to find me. You just need to right now make like a screenshot. You can find me in LinkedIn. By the way, for those 140 some people, on Facebook, I am present, but I am up to here filled in with contacts, so I cannot connect you there. But if you put my name, as you see it on the screen, in LinkedIn, I will be more than happy to connect with you. And this is, I think, the easiest way, because then we can find way to exchange emails if needed. Okay, so this is what I wanted to respond to this comment. If you have any other questions, you can type them maybe in the chat, or you can ask them. Or paneer is on your mind. Okay. There are no questions. Okay. Since there are no questions, I think we are done.
Marcin, there is one into the chat.
Yeah, I responded to this one about the, I see the one about the data sources. So they are in a Zenodo. Okay, and you need to just contact me if you cannot find them. Okay. And if anybody would like to talk about collaboration, find me in LinkedIn and let's talk.
So participants, in case there are no further questions, we would like to thank the speaker. Thank you so much, Professor Marcin, for your time and for your valuable knowledge, and you shared your insights with us. Thank you, Professor. We hope we'll be able to invite you to NIT Delhi next time. So I, on behalf of Department of Computer Science and Department of Electronics, along with my co-coordinator, would like to thank you, sir. Thank you so much, sir. So there's one question. Sir, is there any possibility for chatbot with small data?
Yes, as a matter of fact, I think the one that is okay. I think that the binary one was developed so you can put a small language model on your phone. So if it fits on a phone, on a smartphone, then you can turn it into a chatbot. So a small chatbot, because the size will depend. Of course, chatbot is on top, but as soon as you can make it small enough to run it on your phone, then you can create a chatbot. So apparently it should be available. We may want to look at it, by the way, Professor, for the future with the medical thing, but this is like for the future to see if you can squeeze it on, I don't know, Samsung Galaxy 25 Ultra Pro Super. Maybe it will run a medical doctor inside. Okay. You're muted. Professor Shelly, you're muted.
Yeah. I unmuted myself. Thank you so much, Professor.
It was always a pleasure. It was good to see you. So thank you all very much and have a good evening.
Yeah, good evening, sir. Okay, sir.
Bye-bye.
So, yeah, just an announcement for all the participants. We'll be sharing on WhatsApp the feedback form. and you can fill up the feedback form. It will be open for the next 30